Welcome to Streamline Content Moderation Workflows with AI ML. My name is Liam Morrison, and I'm a data science leader in media and entertainment here at Amazon Web Services. And with me today, I have Anuj Anhuja, who is with Flipboard, and he's going to show us what Flipboard does with the AI ML services later in the session. Let's talk about what we're going to talk about today. So first, we're just going to overview what you might use content moderation for. Content moderation means a lot of things to a lot of people. Then we're going to cover what services specifically you can use in these moderation workflows. And then finally, since there's a lot of different services, we're going to talk about how to bring all of the output from multiple different services together so you can provide content moderation in your application. Then we're going to show a couple demos. After that, I'll hand it over to Anuj to go into the Flipboard use case specifically around these services. So, why content moderation and why automated content moderation? So digital content continues to accelerate. That's a combination of user-generated content and just the explosion of content, both internal and external to organizations, that is being generated with the ease of use of content creation these days. Oftentimes, you need to ensure that all of the content is appropriate to the policies of the application. So you need to make sure the content meets the guidelines. Oftentimes, the content is often in the thousands, tens of thousands, hundreds of thousands of pieces of content. So to do that with manual effort would be significant. So today we'll talk about how you can augment the manual processes with automation to do this at scale. So let's go into some of the use cases. So social media, that's a very common one where you've got user-generated content, you're uploading images, articles, videos. And the use case would be prevent exposure to inappropriate content on those sites. So this is with the increase in social sites, there's a lot of different sites where user-generated content can be generated. Then a different type is broadcast media. So finished content where you've got studios creating shows, creating either reality or scripted content where you actually need to make sure the content meets the compliance of a global market. So content moderation means different things in different countries, for instance. Then you have marketing and advertising use cases. So that's avoiding content that's unsuitable to advertise with a specific brand. Finally, there's e-commerce and real estate. So looking at product house listings, so you need to keep out controversial product listings and make sure you're not violating any policies of your site. All right, so now let's look at the services that AWS has when it comes to content moderation. So the AI services at Amazon Web Services has several different components. Amazon Rekognition, which provides image and video analysis. Amazon Transcribe, which provides speech-to-text capabilities. And Amazon Comprehend, which adds on to that speech-to-text and provides document analysis with natural language processing. So let's go into each of these services in a little more depth. So Rekognition is a large suite of services, APIs inside of the service that provide different things. So you have object and scene and activity, which provides all the labels of what's inside of a video. Custom labels, which we'll talk about later, allows you to really extend to whatever labels are interest to you. Content moderation, which we'll be talking a lot about in this session, which provides the ability to look at specific types of content that might be unsuitable. So nudity, violence, that type of thing. Text is another thing we'll talk about in this session, which allows you to look at what text is in a video or image. So that can come up when you're looking for potentially unsafe words in a video or image. PPE detection, not going to be useful for this session, but that's looking for different PPE equipment, personal protective equipment. Face detection analysis, not necessarily important unless you're looking at redacting faces, which could be an aspect of content moderation if you need to anonymize or redact faces. Face search and celebrity recognition are not necessarily helpful for content moderation, but they're capabilities of the Rekognition API. Video segments, which is the ability to take a video and understand all of the different shots, the different segments. That's interesting for one use case, which is now that you found the unsafe content, you can also identify the shot that unsafe content is in and then edit it out in a editing suite. Live stream pathing, not very helpful for content moderation, so not going to go too far into them. So let's look at that content moderation API, which is really the heavy lifter when it comes to moderating image and video-based content. So you get categories of unsafe content. One thing that's important is we do not provide, say, ratings or a judgment on whether the content is safe or unsafe. We provide all of the tags and hierarchical tags so you can understand, is it explicit nudity? Is it suggestive? All of the different categories that are useful for you deciding what is something to moderate in your content. So one thing worth noting is in late 2020, we had a content moderation update that added a lot of new categories to the content moderation capabilities. So we added 6 new categories and 17 new subcategories, and we've actually extended since then. But these extend into things that also could be used as moderation categories, such as smoking, gambling, hate symbols, alcohol, drugs and drug use, and rude gestures. So these are all additional tools. One thing that's helpful with a service like Rekognition is it's constantly improving, constantly adding new features and capabilities. Moving on to the speech components, Transcribe or Amazon Transcribe is a speech-to-text service. So that allows you to take the speech that's in a piece of content or a call and translate it or transcribe it to text. So it actually provides specific words that are spoken. It also allows you to identify the confidence scores of those words. And then very important from a moderation use case is it provides word level timestamps. So you can find exactly where in the content that potential profanity was spoken. Transcribe also has a feature which is very helpful for real-time moderation of calls, which it can upload a filter list of words. So let's dive into that. So with Amazon Transcribe, you can actually create a vocabulary filter and apply that filter to your transcriptions. So what that will do is it will take any bad word that you define in that list, and there's many lists of profanity. Depending on your use case, you might have a slightly different set of words that you're looking to moderate. One nice thing about the filter is it can mask it, remove it entirely, depending on how you set the vocabulary filter. This is helpful if you're looking to remove the bad word in your moderation scenario. If you're looking to find it for editing purposes, you might not use the vocabulary filter because you actually want to find where in the content that word exists to edit or something like that. So moving on to Amazon Comprehend. So this is a natural language processing tool. So it can be used for content moderation. It has a lot of other capabilities. It can extract all the entities, what's being talked about, key phrases. It can identify PII or personally identifiable information. Not exactly content moderation, but in many of these scenarios where you've got a real-time chat or a social media posting scenario, you also want to protect your users from posting PII about themselves or other people. So PII often falls into a content moderation use case. It can identify the type of languages, but one key capability is the custom capabilities that Amazon Comprehend has. It can do things like custom entity extraction. So you can take that word list similar to the vocabulary filter, or even entire bodies of spoken text and classify that as hate speech or different types of profanity. So I'll show in my demo a little bit of how you might do that using Amazon Comprehend. Moving on to the customization. So Amazon Rekognition has a capability called custom labels. This is very helpful when you have a moderation use case that doesn't fall into one of those categories we showed earlier with nudity, violence, hate symbols. New things are coming up every day, and the ability to react quickly and detect these in your content is important. Another use case is also the brand moderation use case. So you can actually train custom labels, and let's go into how custom labels works. It's an automated machine learning vision service that enables customized image analysis. So it allows you to create a set of labels based on your own content, your own images, and without deep data science machine learning experience, you can build a model to train a model to identify logos or your own identified hate symbols that you're looking for in content. And I'll show that in my demo coming up. So How it works is you provide your content, be it images or videos, and you identify the labels you're looking for in the video. We provide a really good UI. It also can be integrated with SageMaker Ground Truth to really scale out your labeling to a larger workforce or third-party labelers. Step two is, now that you have the labeled content, you essentially click train on the custom labels recognition console, and you've now started the training process. It will train a model. It'll provide you the evaluation, the results. I even provide some ideas on how you could improve the accuracy of that custom labels model. And then step three, you just use it. And I'll show it in the demo integrated right alongside with recognition. So the benefits here: no ML experience. It's low code, no code. You can really just upload 20, 40, 60, however many image reference images you have, and build a model quickly. It's been designed to really excel with not a lot of training data. So we're talking tens to hundreds of images instead of tens of thousands of images. So it's a fully managed service. I'll show it in the demo. One interesting thing is recognition custom labels currently is image only, but the code we're going to share at the end of this session shows you how you might use that with videos, and we provided code to help with that. Speaking of, the code we'll be talking about is the solution called Media to Cloud, which the third iteration of it recently launched on the solutions page. So what we found is finding content and looking for moderation in content often requires aggregating the results of multiple services and then understanding those results in one place. So recognition has, we saw all the different APIs recognition has. Each of those will give you a JSON response with those results. So will transcribe, so will custom labels, and so will comprehend. How do you bring that all together? So the link here below shows you how to get that. This is a CloudFormation template that you launch in your account, and it really simplifies the extraction of these labels for many different use cases, specifically today, content moderation. So there's a lot going on under the hood. It's really designed to help media companies ingest assets into the cloud. We don't need to go into all the services today that are used, but it is following all well-architected principles for security. It's backed by Cognito. It uses Elasticsearch or OpenSearch now for its database or for searching. And it has a serverless methodology for ingesting assets, processing assets, and then finally on the bottom right, how you actually use these machine learning services. So there's a lot to Media to Cloud, but I wanted to focus specifically on the content moderation use cases of Media to Cloud. So let's do a quick demo of Media to Cloud. So when you launch the CloudFormation template, this is what you get in your account. You get temporary credentials. You could use Cognito Federation to tie into your own identity provider. But this is the console. It's a serverless website. Let's go in and start actually identifying content. So I'm going to go in here. We separate the video, photo, and podcasts if you're doing podcasts. I'll go through the upload process because that shows you how you would trigger the different types of APIs. So I'm going to go ahead and upload. I'm going to pick just an image for speed's sake. Once you go to upload it, it's going to upload to S3. You get to choose the different labels. Obviously, moderation, the recognition moderation API is most important, but also text is quite important. Finally, we talked that brand use case. There's also possibly a need for custom labels. I did train a custom labels model just to show how that might be done. And then we talked about how to identify profanity. So I did use Amazon Comprehend to train a profanity recognizer. So when you go ahead and upload the asset, it's going to do a bunch of other things relevant. Let's go look at that asset now. So it's still processing. We use Lambda step functions to actually process the image. It should just take a couple seconds. Again, depending if it's a video or an image, it might take longer. So let's see, it's not done yet. And it is now done. So it has processed this asset. You see, this is a an image of tobacco products. So you get the moderation labels, but you also get the text. So now you can see I've got two different things. So let's look for tobacco, smoking. Let's look for anything we have that's tobacco, smoking, or even vape. So as you see here, I've got four different assets. If you look at the bottom one, which is interesting, it actually is a benign image that actually had that. Let's look where smoking exists in a piece of content. So here's identified to the time code exactly where smoking exists in my content. Let's dive deeper into one asset. So this is an open source movie called Tears of Steel, often used to test video equipment. We're going to process this 12-minute movie through the Media to Cloud, which runs it through Recognition, Transcribe, and Comprehend. And let's look at the labels that come back. Again, today we're just focusing on content moderation. So let's go to moderation. So you can see, similar to the other content, where the moderation issues might be. But also, I just chose two different things, robotic eye and robotic hand, which are specific to this asset. Think of this as whatever you might want to moderate. So I trained it to look for robotic eyes and robotic hands. So this gives you an idea of how to find exactly where in the content. So using OpenSearch, we now can find exactly where these potential issues might be. Finally, we talked about the profanity detection. So now you can find exactly where the profanity detection exists in the content. So that, in a nutshell, is the Media to Cloud solution. I wanted to provide a couple other examples because, as we talked about earlier, moderation means a lot of different things to a lot of different companies. And that's why I'm excited to have Anuj talk about his specific view of moderation at Flipboard. So here's two other examples and one more demo of a couple use cases. This is a blog and code we have in our documentation on how to do image moderation in Slack, for instance. So this uses Amazon AppFlow, uses a very similar process of step functions and Lambda to process the images, look for issues, and then queue up the responses to deal with. Next one, which is what I'll demo, is actually using the Chime SDK. This is actually doing moderation, also sentiment analysis, and even PII redaction of another real-time chat example. So this one uses Chime. We have actually a different one that uses channel flows in Chime that allows you to take action before the content is posted. But we'll show that in the demo. Last thing I want to talk about before the demo is how to validate your moderation issues with human in the loop. We'll talk about this in detail, but moderation labels generated from an AI service will be accurate with confidence scores, but sometimes you need 100% guaranteed accuracy. So oftentimes that's where a human in the loop can be used to augment the moderation to validate this is or is not an issue, this is or is not moderated content. So there's a service called Augmented AI that allows you to review the output of a label and pass it to a human to review in an automated fashion. So for instance, this could be recognition image, for instance, which has native integration into Augmented AI. The response can come back and say, low confidence that this, there's a 50-60% confidence score that this is a moderated image, or high confidence, it's 99, the confidence score is 99.99%. You could, depending on your specific moderation needs, pass those high confidence scores directly to the client application while taking those low confidence scores to be reviewed by a human. So that allows you to review the consolidated labels. You can actually have multiple reviewers put in their answers. So that way you can automate the validation. So if 4 people say it's a moderated image, for instance. The results are stored to S3, which then can be put onto the client application. So let's do the demo of the social media application now. So what you have here is the Chime SDK. I'm going to go ahead and log in to my channel. And when you log in, if you notice in the upper right, we've actually got information coming from Comprehend about the sentiment in the channel, not really useful for moderation, but helpful for understanding if there's a negative channel that you might need to look at. So as you see, the sentiment analysis is running. It's going to say positive, then possibly negative sentiment as well. You can actually look and see the results of the moderation to see if there's an issue. If there's 100% negative in a channel, you might want to look for hate speech, bullying, that type of thing. So to get into the features that are more interesting for today, someone might be posting or asking for people's information. I'm asking for phone numbers. I'm saying, hey, this is my phone number. Here's my social security number. Now, this specific one is actually going to police and redact after it gets posted. The other example in channel flows will actually redact it in line before it gets posted. Depending on your use case, you might want to go ahead and remove it from being posted at all. Then finally, the redaction. So I put some bad words, heck, in this use case. But again, this depends on your library of words. But if you look, it was automatically deleted, and I was sent a moderator bot note that potentially could kick or ban me from the channel. So that's it for my part of the session. I did want to hand it over to Anuj Ahuja, who's going to go into Flipboard and what they're doing with Amazon Rekognition.
Thanks so much, Liam. As he said, I'm Anuj Ahuja, and today I'll be talking a little bit about how Flipboard does content moderation with Amazon Rekognition. Just a little bit background about myself. I'm a senior engineering manager at Flipboard for the core apps team. We build the underlying backend services for various features on the app. For instance, we build the services that run advertising, search, home feed generation, image processing, which is something we're going to dive pretty deep into today, among many other features. I've been at Flipboard for just around 7 months, and prior to that, I was at Amazon for about 8 years as an engineer and engineering manager across various teams. But what's Flipboard? For those that don't know, Flipboard is a content recommendation platform that enables users to keep up with their passions and interests, and publishers, creators, and curators to share their stories. On a daily basis, we serve millions of users and ingest tens of thousands of articles per hour from publishers and users alike. We're on the iPhone, iPad, Android phones and tablets, and on the web, and you can even sign up for a multitude of newsletters, including ones that are customized to your own recommendations. Now, as a platform where anyone can add content, user safety comes first. See, Flipboard users can flip anything from the web and can purposefully or unintentionally share harmful content. As the platform hosting this, we have a responsibility to our users and partners to create a safe environment, partly through moderation. In particular, it's key to note how big of a role images play on the Flipboard experience. If you open the iPad app, for instance, the first thing you see is a giant image of an article from your home feed. As you flip through articles, each one is associated with an equally large image. So it's crucial for us to moderate which images we're splashing on your screen. But how do we do this at scale without slowing down how long it takes for an article to show up in a user's feed? Well, over the years, we've invested a lot in our image processing flow, including added automated moderation. We've rewritten this flow numerous times since 2010, sometimes in Java, sometimes in C++, but as of last year, we rewrote the service in Java. We're using Reactive Spring for dependency injection, OpenCV via Java CPP for image processing, and Project Reactor for non-blocking I/O. We're also using Amazon S3 for our image storage solution. But that's all the image processing stuff. How do we do moderation? Well, to start, we've been using various skin detection techniques, both for moderation and features like cropping and featuring certain parts of an image. But for not safe for work moderation, we've experimented with various tools. One of these was running TensorFlow against NudeNet, which is a database of not safe for work content to help train machine learning algorithms. While this yielded strong results, there were two major downsides that we found. For one, it consumed a lot of memory, and it would have been really expensive for us to keep going. Plus, this would have needed to be self-maintained and would be a huge undertaking for a company our size to upgrade and update on a consistent basis. After all this experimentation, we eventually made our way to Amazon Rekognition. And this solved both problems, among others. For one, it's fully maintained and updated by Amazon, which means we're getting free upgrades in the background without us having to do anything. Plus, obviously, offloading all of that processing saves us a lot of money, and we're going to talk a little bit about that in a second. We're currently living on the 2.0 version of the SDK, and we're integrated using the Rekognition async client. Now, as a side note, we additionally use PhotoDNA to scan and remove photos of child exploitation. This checks photos against a hash list of known photos. You may have heard of Apple wanting to do this on device a while back and then retracting. This is really common in cloud businesses where you cannot store illegal content in your servers. And so we run this through PhotoDNA to make sure we're not storing that content. Now, as I said, Flipboard has a large amount of images being ingested on a daily basis. So how have we scaled that? Well, for one, we have two forms of content. Content that's flipped by our publishing partners like Vox and New York Times, and content that's flipped directly by our users. We only run Rekognition against content our users flip. Trusted publisher content currently bypasses that check. So with that in mind, we're processing for moderation around 90 million images every single day. We're currently seeing a sub-second response from Rekognition, around 700 to 800 milliseconds. But it's not only performant, we've also found it to be highly accurate. It's helping us catch about 65,000 not safe for work images per day, which is significantly more than our own skin detection techniques were doing in the past. Using Rekognition has also kept us under budget. In fact, this week, we're increasing the rate at which we make API calls to Rekognition to speed up our asynchronous processing flow, which is not something we were originally expecting to do. So let's put this all together. I'm a bit of a visual learner, so here's a flowchart of the decision-making process we have here at Flipboard when we ingest an image. Now, keep in mind that we do more image processing work in between all of this, but this is completely focused on the image moderation portion of that flow. So when an article of an image is flipped, we start two parallel flows. The top one is what we call the PhotoDNA check. This one runs our skin detection algorithms and sees if a certain percentage of skin is in that user flipped content. We pass the photo to PhotoDNA to check for illegal activity. If PhotoDNA responds with an alert, we take domain and country specific action. If PhotoDNA does not catch anything, we pass the check and move on. The bottom flow is what we call a Rekognition check. This is where we run our user flipped content through Rekognition. What we'll do is we'll pass an image to Rekognition and then receive back a list of labels. Using those labels, we are able to categorize the image as not safe for work based on our standards. We then apply this internal not safe for work label to the image and move on to the next step. If labels that come back from Rekognition we do not consider not safe for work, we completely pass this check right away. Now, whether or not this picture is NSFW or not, we do store it in our servers, but we reduce the visibility. So for instance, we won't show it on cover photos, we won't show it as a giant splash screen or anything like that, but it is still stored in our system. Once both the PhotoDNA and Rekognition checks are complete, we upload the image to S3 for our clients to access as they need to. So, as I said before, moderation is a baseline to create a safe environment for our users. This is unfortunately a moving target or an arms race that we need to consistently keep up with. Doing this on our own is really difficult, as we've learned through lots of experimentation. But Rekognition consistently improving in the background is giving us increasing confidence that we're keeping our users' experience at the bar that they expected it to be at. This also helps Flipboard as a company focus and further invest in our core competency of creating a beautiful content sharing and recommendation platform. We're going to continue experimenting with Rekognition and actually already have plans on expanding our moderation efforts further this year. Thanks, Liam. Back to you.
Thank you, Anush. So that's a perfect example of how to use these services at scale in production. So how can you get started? So there's a lot of different ways you can get started. Setting up an AWS account and getting started with the AI services. The AWS console has a lot of really easy ways to try out each and every one of these APIs. You can upload images, see the results. You can even see the JSON responses and how you might integrate it into your application. Also, the Media to Cloud solution, which I showed, is a CloudFormation template, which you can run, and within about 20 minutes, you get an email with your credentials to log in and start using all of those services in combination. So we also have pages for each of the services I talked about, so you can dive deep into the features of Amazon Rekognition, Amazon Transcribe, Translate, Augmented AI, Comprehend, all of the different services that we spoke about today. Reach out, contact us. We have specialists and a code that we can help you get started. We also have a very rich partner network, so lots of different ways to get started on your machine learning journey. So I wanted to thank you for your time today, and just remind everyone to fill out the survey. Let us know what you thought about the content, what we can improve. Thank you.